In this video, I'm going to try to demonstrate the use of effective interest rates and how we can use them to solve certain type of problems. Let's consider a situation in which we have a loan for $20,000 and the interest rate, the nominal interest rate per year, it's 8%. That's a nominal per year. But the compounding period is monthly. So that turns out that if the compounding period is monthly, the monthly interest rate is 8% divided by 12. So that's monthly interest rate. Now let's say that you need to pay these in the first case, say 24 months. Okay, the period, the number of periods to pay is 24 months with monthly payments. That's enough for us to compute how much we need to pay. All we need to compute is the payment for if we have a rate of 0.66% monthly and the number of periods is 24 months, and the original loan was for 20,000. The total payment, the monthly payment, will be $904.55. Now, it could be possible that this same $20,000 with a nominal rate of 8% and also with compounding periods of 0.66% could be paid not in 12 months but in also in 24 months, but with say 12 payments. Payments are still going to be 12 or within 24 months, but we are going to have payments um, every other month. So payments every other month. So if that's the case, we need to compute the effective interest rate that would allow us to still use P given A, but now the effective interest rate needs to be the effective interest rate for 2 months, right? Because the rate that you use in each one of these formulas, P given A given P given F, etc., is the compounding rate for from period to period. And in the case of annuities, that would be from annuity to annuity. So if we want to be able to use P given A, we need to compute the effective interest rate for every 2 months, right? Let me say payments every other month means months between payments is 2. So the loan is still $20,000, and the nominal rate is still 8%, and the monthly rate is still that number there. But now we need to compute the effective interest rate. So the effective interest rate for 2 months is 1 plus the monthly interest rate remember we did 8% over 12 to get the monthly interest rate, and we're going to raise it to the power of 2, and then we're going to subtract 1. So now this is the interest rate for 2 months. And now we have enough information to compute the payments. Now we're going to have 12 payments every other month, but 12 bi-monthly payments. Is the payments P given A of, or A given P rather. The rate we're going to use is the bi-monthly, and then we still have 24 months to pay, but that means that we're going to make 12 payments only. And the original payment was 20,000. So now, the original loan was for 20,000. So now we have $1,815.12. Notice that this quantity is larger than 2 times this quantity here. We can compute another example of this. Let's consider again the same loan with the same interest rate. With the same compounding period, so we have the same monthly interest rate. Well, let's say now that we're going to make payments every 3 months. So that means that now we're not going to have 12 payments. We only need 8 payments. Okay. So we need to compute the effective interest rate for payments that happens every 3 months. That is, we need to take into consideration the effective interest rate for 3 months. Let me write here just for 3 months. The effective interest rate is 1 plus the monthly interest rate raised to 3 now. 3. I'm going to subtract 1. And that means that the interest rate for 3 months is going to be 2.013. Now you can compute now 8 quarterly payments to be equals to payment of rate is the quarterly rate 2.013. Number of periods is 8 quarters, that is 2 times 4 for the first and second years, and the present value is the same, it's just $20,000. So if you were to make quarterly payments, you would have to make payments of $2,731.77, and that's how you use them. So in summary, we need to make sure that the effective interest rate that we use matches the distance between what we consider a period. When we divide the 8% by 12 here, this expression, and we divide by 12 is because there are 12 compounding periods in a year. Always the nominal rate should come in yearly terms. And from there we can use the number of compounding periods to compute the monthly or the weekly or whatever it's needed in terms of the compounding process, just by dividing the number of periods within a year. In this case, there are 12 months. We divide by 12. If the compounding period was 6 months, then we divide by 2. And once we have that, we just take into consideration what's the distance in terms of those compounding periods from what we consider a period and the next period, when we take into consideration when the cash flows are going to happen. So I hope this video is helpful, and I'll see you next time.